It's your meeting, sir.
Okay. Well, this is the MEOS meeting, if you haven't been to one before, and it's great to see you all. And we have, very fortunate to have Dr. Andy McIntosh. He has a PhD in thermodynamics and a doctor in mathematics and a doctor in about 100 other things. So he's Professor Emeritus from Leeds University, which means he's retired, but don't call him retired. Emeritus. And I think he still does some work with Liberty University here. And so anyway, he's done a lot of research and really kind of dedicated his life to validating the creation story.
Thank you, Cameron. Thank you very much. And may I thank Myers for having me. And I just want to share with you some little lessons from the wonder of hearing. And just to mention that I am involved with truthinscience.uk. I mention it for prayer because I have a prayer letter which I was going to put out. I just got a bit distracted trying to get my projector working and then the sound. But if you'd like to support my work, there is a prayer letter sign-up sheet, and I'd appreciate prayer, not only for the meetings that, of course, I'm doing here and other places, but also for this organisation, truthinscience.uk, which we set up some years ago for preparing. Well, there's a number of things we're doing. You can go to the website, you can find out that we've produced a Transgender Agenda DVD, which is available to download if that's something that you would like. A resource on it shows scientifically that it's absolute nonsense to say that you can change your gender. It's scientifically absolutely impossible. You can't do it. You may change the outside, but you can't change the XY and the XX inside. That's the issue. And but there's other things we've produced, like DVDs on dinosaurs and others, which the one on dinosaurs will eventually be downloadable. It's not yet in that form. Then there is this summer school that we run every year, and we had 120 young people last time. And we are preparing them for going up to university and college. Not only are we teaching them about creation against evolution, but we're teaching them to be ready for the woke juggernaut that they will face, not just in the sciences, but especially in the humanities. So we've actually developed the summer school to actually deal with these crucial issues that young people are facing. We are facing a very evil system in academia. I wouldn't turn it doesn't necessarily. I like to be able to see the eyeballs of everybody, just to make sure they don't
I think it's okay.
go to sleep, and to encourage them to keep their ice creams, keep away. So would you pray? That's really what I'm asking. We had 120 last year. There they are, and we had all these young people, some older ones as well, and we had a great time in the middle of the country. Our country is dark and it needs a lot of input of light from those who are Christians. And the trouble is the church in England doesn't see the issue, just like here the church doesn't see the issue. You obviously wouldn't, well, unless you happen to be over there, you wouldn't obviously want to travel over the pond just for that. But you can pray for it, and you might even get some ideas to do something similar here, to prepare young people for going to college. I'm sure that there is all sorts of things going on, but there is a great need. And the books are there. The book that I'd recommend is the book which is open here, which is the Wonders of Creation, and you might find that a good Christmas or birthday present. That's $25. This one is $10. Then the small ones, which are $2, these are $6, and the little ones, which are tracts, Are You Really an Atheist, 2 for $1. So you might like to take some of those to give out to people who are not yet believers. And I prefer it all to be taken. I don't really want to be taking stuff back with me tomorrow, but so you might want to clear them out tonight, but it's up to you. I've worked a lot in acoustics. I've worked on combustion and its interaction with acoustics. And as I played just now, I just played to you now, I like to do demonstrations sometimes for young people. This little lad has grown up by now, but this was many years ago, where I was demonstrating that flames, which are a source of vibration and a source of vibration themselves, that vibration can get amplified by what's called a Rika tube. Like this. Just have a look at this. And we put it over this. Well, that was really to demonstrate that I've been working in that type of area. Obviously, today's talk is not to do with combustion, although I do a talk on combustion. It's all about the bombardier beetle, but I'm not doing that one today. I'm talking about hearing, and I know about how pressure waves behave, and in some cases pressure waves could grow and become beasties called detonations. So there are real dangers of hazards due to pressure waves. We're nowhere near that sort of level. We're right at the minuscule acoustic level. You're not aware that as I'm speaking, I'm disturbing the atmosphere, right? There's a tiny little pressure disturbance reaching your ear, which is then a marvel as to its translation into signals which your brain understands. That's what we're dealing with tonight, and it really is a wonder. I said this morning a number of things, but I will just, when I was at ICR, but I'll just mention some of them. For instance, I quoted this verse from Psalm 111, verse 2, on a radio program that I did this morning with, not radio, it was a podcast for ICR, Institute of Creation Research, and it was a joy, by the way, Jake, to be with you and others there. I really appreciated your welcome. I just love the work that ICR is doing. They're ahead of the game on many areas, in my view, doing great work, and they need support as well. Anyway, Psalm 111 verse 2 says, "The works of the Lord are great, sought out of all them that have pleasure therein." Let me give you another verse which recently I've been greatly blessed by. Proverbs 25 verse 2 says this, and it's worth remembering. It is the glory of God to conceal a thing, and it is the honor of kings to, let me get the exact phrase.
Reveal thing.
No, it's not revealed, it's not revealed.
Uncover.
To make it known, if I remember rightly. It's the honor of kings to make it known, or to make, let me read it correctly. Yeah, but the honor of kings is to search, that's the word, to search out a matter. It's the honor of kings to search out a matter. I'm no king, and I'm not trying to say I'm anybody special. In fact, all of us, when we become Christians, are kings and priests before God. And it's the honor of kings to search out a matter. So the guys at ICR, they're doing a great work. They are searching out the way things work. Randy Galuza, Dr. Randy Galuza, who's a wonderful leader of the ICR, he's a medical man, and he loves to work out how things operate in the biology. Jake has studied a number of areas in the physics of climate change. He's done that, and he's done other things which he's working on at the moment on how come that there is evidence that creatures were larger in the past, and he links it with maturity, the age they come to maturity. He was telling some people about that earlier. And to search this out takes energy and time. As we search out hearing, we will be utterly amazed as to what God has done. The Bible does refer to hearing. For instance, Proverbs 20, verse 12 says, "The hearing ear and the seeing eye, the Lord has made even both of them." And in Psalm 94, it speaks of him planting the ear. And he that did that, shall he not hear? He that formed the eye, shall he not see? And you can see the miracles that the Lord did, which involved making people hear and making people speak who couldn't speak. So when the Lord was asked by John the Baptist whether he was the Son of God, or whether you are the Christ, was actually the question, he said, he didn't give a direct answer. He pointed to the miracles which had been prophesied would accompany the Christ. The blind received their sight, the lame walk, the lepers are cleansed, and the deaf hear, and the dead are raised up. What do you think, John the Baptist? And he was including the deaf hearing. So let me come to the real issue, which is how do we hear? And I need to say a little bit about what is sound. Sound, as I've already said, is vibration of the air. If I took the air out of this room, apart from the minor detail that you'd be dead because you wouldn't be able to breathe, just giving you that just for a moment, you wouldn't be able to hear because the gas is vibrating and transmitting the sound wave, which travels of the order of 600, 650 miles an hour, somewhere in that region. It varies according to the density and so on in the air and the pressure. Sound has a frequency. I won't spend too long on this, but you have a vibration frequency, call it a tone or a note on a piano. It goes up. The more it vibrates, if you're vibrating very fast, then we say high frequency, higher notes. Think of it as notes on the piano if you're not used to the engineering term of HZ, which stands for frequency. And not only does it have a frequency which can go right down to 20 cycles per second and up to 20,000 cycles per second, speech is somewhere in the region of 4,000 cycles per second, but it also has an amplitude. And I won't go into the great details here. A Pascal is actually a vibration which is equivalent to 1 Pascal, which is to do with the force per unit area for Newton per meter squared, as it says here. That's what a Pascal. But let's not get involved on the detail here. We usually translate this into decibels, which I won't go into all the ins and outs of the translation there. It's quite a complicated mathematical connection involving logarithms. Normal speech is about 40 to 60 decibels that I'm using now, right? 130 decibels, you will be in pain. I went to a concert once which my son was running for his girlfriend's 40th birthday, and boy, was it loud. I couldn't hear the person over the table that I was speaking to, and my ears were resounding with it when I went outside. So probably not far away from 130. A jet engine, 100 meters away from the end of the runway. If you imagine Fort Worth, you'll see an aircraft turning on ready to take off. 128 decibels. A rock concert, 120 decibels. Don't know whether I've got anybody here who's tempted to go to rock concerts. You need to be aware there are dangers for your ears. Human hearing, and it's true for all mammals. There is an outer ear, a middle ear, and an inner ear. The middle ear is going to get very interesting when we come to looking at that. It has tiny little bones, which I'm going to mention to you and say a little bit more about. But let's start with the outer ear. The outer ear is not just any old shape. You might think that this shape it's not very attractive. You don't sort of see any real beauty in ears. Well, actually, that shape is not incidental. It's deliberate. The shape is such that the vibrations of the air are being funneled into your ear canal, which is about 2 centimeters long. And what is more, the shape of that ear tends to catch the area around human speech. It's not the same, for instance, for a cat or for a dog, whose frequencies that they pick up are naturally much higher. They pick up very easily high frequency sound. A dog whistle, if you've ever studied shepherding dogs, shepherding sheep rather, you use a dog, usually a collie, sheepdog, which will have ears, all dogs have ears, which hear at a much higher frequency than we do. They hear right up to 40,000 cycles per second. So if you have a dog whistle, it goes right up to the high frequency and you can't hear it, but the dog can. Cats, not that I'm a great lover of cats, they hear right up to 60,000 cycles per second, 3 times the range that we have. And that is why, by the way, a dog, 40,000 cycles per second, it can hear the high frequencies of your vehicle, and it knows when you're coming home, and it will start yapping to the persons at home. Probably your dog, Darling, probably does it when Cameron is driving down the road. Maybe Judy knows that Cameron's coming through what the dog does in response to the noise. And you may be a street away and the dog hears it because he hears the very high frequencies which travel quite a fair distance. So your ear is designed for hearing the 4,000, 5,000, 6,000 cycles per second. And this is where what I said earlier about resonating, I didn't call it resonance, but I talked about the vibration of the flame actually interacting with the natural frequency. We call it the organ pipes oscillation, which I showed you earlier. It was a flame in that case. But it doesn't matter what the source is. We're not talking about flames, but now we're talking about the vibration that my voice is making, and you want every means possible to amplify it, right? So I've already said that naturally the ear tends to bring in the frequencies which are associated with speaking. What do I mean by resonance? If you have a Coke bottle and you blow over it, the old glass ones particularly, you'll get a sound, right, which is the resonance, the natural resonance for that bottle. Think of a glass, a wine glass, maybe at Thanksgiving or at Christmas, you know, you've got a celebration, and you wash up the wine glasses, get a bit of soap on it, and you can play with this next time you have that celebration. Just to get your fingers wet, just a slight bit of soap, and you run it across the glass, and you'll notice that there's a pure note comes from that glass. You can hear it. Supposing you get that note from some amplifier, you know, which is playing exactly that note, you'll find that this is what happens. The glass will start vibrating in sympathy and could shatter. That's what resonance is. It amplifies. If you happen to strike the right frequency, which is the frequency of the glass, it will amplify it and even break it. In fact, engineers should have known better when they were building the Tacoma Narrows Bridge. This was way back, I think, in the 1940s, and the car happened to be travelling across, and I think it finally collapsed. I don't always want to know what happened to that car. Maybe the people did manage to get out, who knows. But in that case, the wind was exciting the natural frequency of the bridge, which vibrated in sympathy until eventually the whole bridge collapsed. Musical instruments operate in the same way, wind instruments that is. If you're playing a flute, you're changing the natural frequency of the cylinder, which is really what the tube of a flute is. And if you perhaps change the place where you have an opening from that to the bottom case, where you've got the open hole in the middle, then you change the frequency of what that flute is playing, and that's how a wind instrument works. So the outer ear is not just an ear canal, which I've mentioned. It is actually small enough such that you can't get your little finger in, but nevertheless large enough to take the disturbance in the air coming in and resonating with that disturbance. Let me tell you what natural frequency 2 centimeters is connected with. 2 centimeters is connected with none other than 4,000 cycles per second. If you're an engineer, you want to know the maths of this, 2 centimeters corresponds to 4,000 cycles per second because of what's written at the top left, that the speed of sound is the frequency times the wavelength, which means that if you're dealing with a quarter wavelength, which you are, when you're actually, look at the top diagram there, you've got a quarter of the wavelength because you've got the tube open here, and it's effectively closed at the eardrum. So we're looking at as to what that distance is. Well, that distance has to be whatever the wavelength is divided by 4. We're trying to find what the natural frequency would be then for lambda over 4 is equal to 2 centimeters. Well, if you do the maths, which is top left there, C then is equal to 4F times L, where L is this length of the ear canal. The speed of sound is 320 odd meters per second. You put all the numbers in, 4,000 cycles per second corresponds to, 2 centimeters corresponds to 4,000 cycles per second, which is right in the middle of the speech range. So our ears, our human ears, are designed to understand speech, whereas the ears of a dog have a different length, right? It's actually smaller and it's tuned into much higher frequencies. It also has a right angle bend in it, so does a cat. So the principle of how we hear is the same in all mammals, but the adjustment of the length will be determined by whether you're a human being, a dog, or a cat, or other mammals. Let's now come to the middle ear, where it begins to get extremely interesting. We have 3 little bones in the middle ear. The first bone is the hammer, or the stapes. The next bone is the anvil, and that has another name, which I'll come to in a moment. Sorry, the hammer is not the stapes. I'll give you the proper name in a moment. I made a mistake there. Let's go on the names which are on that diagram, and I'll give you the other names in a moment. The hammer, the anvil, and the stirrup. The other names are, and I'm sorry I said it wrongly just now. It's the hammer. The technical term is the malleus, which is connected to the eardrum itself, which is vibrating. It's a little membrane which is vibrating as a result of the sound wave coming in. The hammer is like a drumstick connected to the drum. The drum is vibrating now, we're doing it in reverse, and the hammer is connected to the drum. That hammer is the malleus. Then we come to the anvil. The technical term of that is the incus. I'll do it in the direction you've got it, so you've got that hammer here vibrating, the eardrum, so that's then pushing against the anvil, which is the incus, the technical term. And the last bone here is the stapes, and the loose term used is because it looks like the stirrup of a horse. It is called the stirrup. So you've got the hammer, anvil, stirrup, or malleus, incus, and stapes. So these are highlighted here, and they are connected to each other, not fused together. They are supported by ligaments, small ligaments, and those ligaments keep those little bones in place, such that the hammer moves against the anvil, and the anvil then moves against the stapes, which is the piston. What are these three bones doing? They are another means of amplifying the signal. That which started off as a small little vibration here, right, is amplified to a much larger vibration here. And you are going into another membrane. You've got a membrane vibrating here. Now you're pushing against another membrane, which is going to connect you to the inner ear. So this is a mechanical transition from vibration in air to vibration of three little bones, right, which is a mechanical device, which is moving into vibration in the inner ear, which we're coming to, which is not vibration in air. It's vibration within a liquid. And if you know anything about fluids, a liquid is essentially not compressible. Air is compressible. We can push a bicycle pump in a little bit, then you can feel the air resisting it. You try and do that with a pump, a bicycle pump, and fill it up with water. You wouldn't be able to push the handle down at all. It becomes a water pistol, great fun, but you're not going to actually get the water to compress. Very, 0.1% you might manage, but you can't really compress liquid at all. The liquid, therefore, has to go somewhere. We'll come back to that. These three little bones that I've been referring to, against a dime, I think it is, or is that a 5-cent piece?
Dime.
It is a dime. Okay, so against a dime, it's exceedingly small, these three little bones. Here are the three little bones, if you'd like to pass that round. You see how small they are. Now, these three bones are the only bones in the human frame, and it's true of all mammals. These three bones are the only bones which don't grow. They are the same size when you are born as to when you might die, in your 90s or earlier, whatever. When you die, those are the three bones which have not grown. And that's a jolly good job, because otherwise your ears would have to grow with them. They become massive things. Now, why do I say this? Because people try to argue that the ear bones of mammals have evolved from the jaw of a reptile. That's what evolutionists teach. Seriously. It's absolutely extraordinary. But that's what they teach. And let me show you what they actually say. I called it a tale of two jaws. And so we're talking about the malleus, the incus, and the stapes. So this is the hammer, the anvil, and the stirrup. And what they say is that the malleus, which is not in a reptile, and the incus, which is also not in a reptile, that those two bones came from the lower jaw and the upper jaw of the reptile, because they say, correctly, that the jaw of a crocodile or the jaw or even of a snake has a different set of bones than a mammal. We have a completely fused lower jaw, not totally fused upper jaw, but certainly we have less bones than a reptile jaw. And it's true that a reptile jaw has another bone there and another bone there in the upper and lower jaw. So they imagine this story that the lower bone of the reptile moved, changed shape, and amazingly became the hammer of the middle ear. And then they, having said that extraordinary story, they now some talk about an even more extraordinary story, that at the same time, this bone of the upper jaw moved and became the incus in the mammal hearing system. Well, that sounds a wonderful story, but it has quite a number of problems with it, because you've got to make sure that the ligaments are in place to hold those bones together, and before you even get there, you've got to make sure that the shapes are exactly right. And of course, the shape for the jaw, use in the jaw, is for a totally different purpose. And there is one fatal issue. In fact, all of these are fatal to the whole theory. Those little bones are the only bones that don't grow. Have you looked at a crocodile jaw recently? Have you had a good look inside? I don't think it's a good idea, but you might have noticed that crocodiles start off as rather lovable little things when they're born. They're only about that size. And you see this little jaw, you don't worry about it then, do you? But you know full well that the jaws of crocodiles and alligators become huge, fearsome things as they come to adulthood. In other words, the jaws grow and grow and grow. So you've got a big problem in trying to say that those bones have come from a reptile. Even Richard Dawkins realised he had a bit of an issue. He put it as a footnote in his book, The Greatest Show on Earth. Incredible, arrogant title that he has for his books. He says, the lower jaw, a single bone in mammals, the reptilian lower jaw is more complicated, and thereby hangs a fascinating tale that I reluctantly omitted from this book. It is an amazing feat of evolutionary legerdemain. The smaller bones of the reptile jaw were co-opted into the mammalian ear, where they constitute, and this bit's correct, all the rest is nonsense, where they constitute an exquisitely delicate bridge to transport sound from the eardrum to the inner ear. That last bit is correct. What does legerdemain mean? Well, if you look it up in Webster's or in the Oxford English Dictionary, you'll find that it means sleight of hand. Synonyms might be artfulness, chicanery, conjuring, craftiness, cunning, deceit, deception, hocus pocus, manipulation or trickery. Brian Cox, who's our sort of David Attenborough attempted replacement, I don't think he comes anywhere near David Attenborough really in what he does, but he says this, listen to it. Oh dear.
Around 210 million years ago, the first mammals evolved, and unlike our friends the reptiles here, mammals have a jaw that's made of only one bone. A reptile's jaw is made of several bones fused together. So that freed up two bones, which moved and shrank, and eventually became the malleus, the incus, and stapes. So this is the origin of those three tiny bones that are so important to mammalian hearing.
If you have to resort to flick books to prove your point, I think that says more about the dreamer than it does about reality. Would you not agree?
Yes.
He's got no basis really for saying what he was saying, and yet he has been made for a while. I think he was the head of the Institute of Physics for a little while. I think he needs to go back and learn his physics properly. Actually, one article is interesting because it admits that there is a problem here. It is remarkably well documented in the fossil record. Actually, it's not, but this is what it says. That the evolution of the mammalian jaw still poses the paradox of how the bones of the ancestral jaw joint, could function both as a joint hinge for powerful load-bearing and load-bearing mastication, and also as a mandibular middle ear that was delicate enough for hearing. Let me translate that into proper English, right? Or common English. What this is admitting in this letter to Nature, which is a very prestigious journal, what this is admitting is that to say that the evolutionary origin of these three little bones has come from the jaw means that you've got a stage where the poor creature needs to eat. That's what mastication means. It's got to use its jaw, right? Well, how is this creature going to use its jaw when some of its jaw is busy moving around and